Okay, put it there and it just toasted. It feels good. All right, we're live. So today we're going to talk about 3.6, which is rational functions. Why is that moving? I don't know why. Okay, so does anybody know what is a rational function? Michael knows.
Right, I do. Not. I think that they'll have integers.
Now, how integers, we're going to be using mostly integers, but that's not the distinguishing characteristic. Haley knows. Or Bailey knows. No idea? You guys want a hint? It has the word ratio in it. What does ratio mean? What's ratio deal with? Debbie knows. No? Stephanie? Something to do with fractions. Something to do with fractions. Very good. That's exactly right. So it's the F word, fractions, right? Okay, no cussing tonight, though. All right. So, yes, it does deal with fractions. Let's deal with, back in, I think, week number 1, I told you I wanted you to graph y equals 1 over x. Remember what that looks like, Joey? You don't? No. Lauren remembers.
Is that the one that's like in the top right? As opposed to the over.
Okay, so she air drew it very well. Okay. Looks something like this. And does it touch the axes? No, because what?
It never equals 0.
Never equals 0. So it never touches either axis, right? So we have asymptotes here. This one's y equals 0. This one's x equals 0. Okay. Now let's talk about why there are asymptotes there. Okay. So, Maddie, do you remember what the domain is?
No.
What's the domain?
It would be negative, something like that.
Don't put it in the notation because that's too complicated. When we have a fraction, what do we need to be worried about? Yeah, we can't have 0 in the denominator. So your domain is
Greater than 0.
x cannot equal 0. It could be greater than 0, it could be less than 0, it just cannot equal 0. And that's much easier to write than negative infinity to 0. Okay, so the idea here is your domain, that becomes your vertical asymptote. Okay? That is this asymptote right here on the x-axis. Now we know we have another asymptote, and so when we're dealing with, I'm going to turn out this light. Is that okay? Still? Oops, lost your drink. It's a good thing it has a lid. We're either going to have a horizontal or we're going to have an oblique. An oblique is a slant asymptote. Okay? So as we look at this fraction here, the entire fraction, what happens to that fraction as x gets really big? If we go from, what was that? Let's go, if we go 1 over 10, and then if we make x 100, it'd be 1 over 100. And if we make x 1,000, it'd be 1 over 1,000. What's happening to the overall fraction? Being very small or very close to, what'd you say? The axis, which is, what value is the axis? Yeah, so y is going to get very close to 0, right? And it doesn't matter if it's a positive or a negative. If I go negative 1 over 1,000, that's still going to be very close to 0, right? Okay? And so that's why we have this horizontal asymptote. Okay? And so the idea here is we're going to do more complicated functions than this. And the first thing we're going to want to do is figure out where the asymptotes are. Okay? So let me give you some nice little rules to think about here. How about if we said, okay, so here's some rules for asymptotes. For maybe, in fact, I'm going to call these horizontal or oblique. An oblique usually means slant, although you could have a parabolic asymptote. We'll do that tomorrow. Okay? All right. So remember, with your vertical asymptote, all you're doing is you're checking for your domain. For your horizontal or your oblique, what you want to do is you want to compare. Maybe I'll put this as the first thing. Compare the degree of the numerator to the degree of the denominator. Okay? Now, let's talk about this first as we go back to this previous problem I just did. It might be easier to tell me what is the degree of the denominator. Let's do that one first. I'm going to pick on James. What is the degree of the denominator here?
1.
1? You sure?
Yes.
Okay, good. That sounded confident. What's the degree of the numerator?
Also 1.
No.
0.
You sure?
Yes.
Okay. All right, it's degree of 0. Why is it 0? We could have written this, if we wanted to, as 0x, right? Plus 1x to the 0 power, right? Anything to the 0 power is 1. Okay? So your degree of the numerator is 0, and your degree over the denominator is 1. Okay? So, rules for horizontal or oblique asymptotes. Okay? Number 1, if the degree of the numerator is less than the degree of the denominator, then you have an asymptote at y equals 0. Okay, does that make sense? All right, rule number 2. If the degree of the numerator equals the degree of the denominator, then you have an asymptote at the simplified leading terms. I'll give you an example of that in just a minute, okay? And then, of course, the other option is rule number 3. If the degree of the numerator is greater than the degree of the denominator, use long division to find the asymptote and ignore the remainder. Okay? All right. So let's do an example here. Let's say that I have some rational function r of x equals 3x plus 5 over x plus 2. Okay? So, Nathan Allred, can you tell me what the domain is?
Yes.
You can guess? We'll see how good a guesser you are.
Everything except -2.
Right, and how did you get that?
Because -2 plus 2 on the 5
Yeah.
there would be 0.
You looked at the denominator. So the domain is x cannot equal -2. Now, if that's the domain, where's your vertical asymptote?
That's on x equals
X cannot equal -2. It's the same thing. Okay? Good job. You're a good guesser. Hopefully that keeps up on the test, right? All right, now let's talk about the degree of the numerator over the denominator. We're going to pick on Daniel. What is the degree of the numerator right here? 1. And the degree of the denominator? Also 1. Okay, so which of these 3 rules applies?
It's the second one.
The second rule, okay? So we've got the second rule, the degree of the numerator equals the degree of the denominator. So the asymptote is at the simplified leading terms. And so all I'm going to do in this case is I'm going to look at the leading terms, which is y equals 3x divided by x. And that simplifies to 3. So you've got an asymptote, a vertical asymptote at y equals 3, or y cannot equal 3. Okay? Now, let me ask you a question.
You get it in horizontal.
Oh, sorry, I meant horizontal. Yep, you're right. Thank you. I have a horizontal asymptote at y cannot equal 3. Now, if the vertical asymptote is the same as the domain, what do you think the horizontal asymptote is? Same as the range. So that is also the range. Y cannot equal 3. Okay? All right, so as we draw this, okay, we've got a vertical asymptote of x cannot equal -2. We have a horizontal asymptote at y cannot equal 3. Okay, now we just need to figure out how this is going to work as far as graphing goes. So it could be here, or it could be here, or it could be here, or it could be here. Okay? So basically, the easiest thing to do is to look at your domain. Just need to pick some x's in here and also in here. Okay? On either side of your vertical asymptote. Okay? Now, a couple other things that might be useful here. We might want to find some intercepts. So Javier, how would I find intercepts? Set what equals 0? Okay, well, no, I don't want to set the numerator and the denominator equals 0 because then I'll get 0 over 0. But if I set x equals 0, so let me put x equals 0 in here, what's left? Because if x equals 0, then that goes away, right? So what's left? It's actually positive 5. So yeah, so when x equals 0, so r of 0 equals 0 plus 5 over 0 plus 2, which equals 5 halves, which is 2.5, right? So when x equals 0, y equals 2.5, which is right there. Okay, so Andrew, since Javier found the x-intercept, where's the y-intercept? Or son, he found the y-intercept. Where's the x-intercept? How do you find it? Hello? Well, he said x equals 0. So set y equals 0. So if I do the same equation, if I say 0 equals 3x plus 5 divided by x plus 2, now I just have to solve that, right? Come off the screen. Thank you. Okay. So how do I find that? How do I solve this equation here? Multiply both sides by x plus 2, and then that's just going to go away, right? And then I'm going to subtract 5. So negative 5 equals 3x divided by 3. X equals minus 5/3, which is negative 1 2/3, right? So negative 1 2/3 is about right there, right? So I can see here that in this case, it probably goes something like this. So it's not going to be above here. Now, the question is, what does it do in this region? How would I figure that out? Actually, I already know. I have found the x and the y intercepts. So it's not going to go here, right? Because it would have to intercept right there, right? So it's got to be up here. Does that make sense? Now, if you're not sure of that, how can we prove that I'm correct? Rory, what do you think? How could we prove that I drew that in the right place? Well, it's not going to go through the asymptotes because that's why they're there. Plug in which point?
On the other side. So
Yeah, any point over on this side will work, right? So give me a point to pick.
4,
Negative 4? Okay. So we're going to do r of negative 4. So r of negative 4 is, with this equation,
So 3 times negative 4 plus 5.
plus 5 over
Negative 4 plus 2.
negative 4 plus 2. Okay, so 3 times negative 4 is negative 12 plus 5. 7. Okay. Negative 4 plus 2. Negative 2. Negative 2 divided, or negative 7 divided by negative 2 is a positive 3.5. Okay? So 3.5 is above 3, right? So if I go out here, and it's above 3, so I probably should have drawn it right there. Now I'm even more accurate than I was before. Okay? But it's not going to cross the asymptote. Now, I'm going to give you guys a bonus that I did not give my other class today since we've got 3 minutes left. I'll tell them tomorrow. Okay? So, I'm going to give you a bonus over here. It is possible to cross a horizontal or an oblique asymptote. Okay? How do you know? If it's possible. That's the big question, right? That's what you guys want to know. Okay? I didn't even check on that one, although I probably should have. And really, you should check them too, okay? So here's how you know it's possible. We said over here our range was y cannot equal 3. So here's what you're going to do. You're going to set 3 equal to the equation 3x plus 5 over x plus 2. Okay? We're going to solve it. We're either going to get an answer or we're going to find out it is impossible to solve. Okay? If we get an answer, then it crosses at that point. If we get an impossible solution, then it doesn't cross. Does that make sense? So Tyler, can you help me solve this?
Yeah, multiply both sides by x plus 2.
X plus 2, x plus 2, so that gives me 3x plus 6 equals 3x plus 5. Subtract the 3x from both sides, and I'm going to get 6 equals 5. Is that a true statement? Only when I owe you money, right? Okay, so that is not a true statement. So therefore, 6 does not equal 5, so it does not cross. Okay, now if I had gotten, let's say I'd gotten like x equals 3 or something. Okay, then in this case, because y equals 3 and x equals 3, I would know that it would cross at 3, 3. And so that is possible occasionally, okay? So we didn't get to cover a lot of 3.6. So as far as the homework goes, what I'm going to say is, I think you guys can do up through 17 pretty easily. The quiz will be on up through 17 tomorrow, okay? And oh, by the way, it's time for another test, right?
Yeah.
So we'll have a test on Thursday. So tomorrow we'll probably finish 3.6. That'll probably be a good place to stop. We'll have a review on Wednesday and then a test on Thursday right here.
What are you going to put in the study guide?
I will probably try to put it up tomorrow night. So how